Good evening, ladies and gentlemen, and a very warm welcome to University College Dublin for this evening's event, which is one of a series of public provocations under the broad rubric of communication, knowledge and the citizen in a global environment. And the series is supported by the generosity and enthusiasm of Dennis O'Brien and the Communicore Group, and I'm happy to say that this has provoked public interest, engagement and debate across a number of themes implicit in the transformation of and access to the sharing of knowledge. It's a great privilege for me to welcome our speakers this evening, James Lovelock and Frank Convery. James Lovelock has had a long, distinguished and controversial research career. He is widely recognised as the prophet of global warming, and tonight he will be in conversation with Professor Frank Convery. Frank is Professor of Environmental Studies and Director of the UCD Earth Systems Institute. And Earth Systems is one of 4 key strategic research priorities for the university, the others being Global Ireland, Health and Healthcare Delivery, and Information, Computation and Communication. So please join me in welcoming our speakers for this evening, Frank and James. Thank you.
Thank you very much indeed, Brian. It's wonderful to be here, and I would like to join Brian in welcoming everybody. I would like also for us to give a very warm welcome to Sandy Orchard, who's James's wife and who's with him. So, the format that we're going to follow is this. First of all, I'll do a little bit of shameless huckstering about our Earth Systems Institute. Then I'll do a little bit of perhaps less shameless huckstering for the book, which I think is a terrific read. And then we'll move into the program proper. The first, because as you know, there is a provision in the Irish Constitution that says that whenever a visitor comes to Ireland, the first order of business is to find the Irish connection. So we'll work through that obligation, which also happens, I think, to be quite interesting. And then we'll turn to James's work. And my thought here is to take it in kind of stages, to dwell, first of all, on his Gaia career, although it's a fairly seamless sequence, I suppose. But he did a lot of fascinating and interesting things in the earlier stages of his career that are well worth, I think, us exploring. And then we'll move to Gaia, and my thought there is to do that in 2 parts, to dwell a bit on the analysis of the problem and the issue and the concept, which he has exposed brilliantly, and then address in the final module the solutions he's proposing to address this challenge in regard to climate change specifically. We'll talk for 45 minutes to an hour, and then we will open the floor for discussion. The discussion will involve you coming to the front where we have 2 mics, and you'll be invited essentially to make your point or your question, and obviously to be as pithy and focused as you can be. So that's the drill. The Earth Systems Institute here in UCD is something we've kind of developed or are developing quite recently, and it essentially derives from the fact that we have tremendous capacities across all of the science and engineering disciplines that focus from time to time on Earth systems issues. And we have tremendous talents in the kind of economic policy analysis side of the house and the statistical and modeling and computational sciences end of things. But we've never brought everybody together to try to create a real dynamic interaction to address challenges, and that's what this Earth Systems Institute is about. We're at the early stages, so I'll be listening very carefully to James, because he, of course, is in his own embodiment an Earth Systems Institute multiplied by 1,000. So we have to be humble, obviously, but I think we can learn a lot. We have some kind of principles. We're going to collaborate with sister institutions in Dublin and elsewhere. We're going to be multidisciplinary. We're going to focus on Irish issues that have global import. So it'll be a kind of an interesting combination of the local and the global and so on. We'll kind of come back to that a little bit later. This book, which is being promoted at the moment, I just read it in the last few days, The Vanishing Face of Gaia, A Final Warning. And it's a terrific read, as I think you'll learn as we go through our conversation. James is a wonderful conversationalist and a great writer, and he has a great style about him that is both forthright and humble at the same time. So I recommend that you not be without a copy, and I've heard that he'll be signing copies afterwards. He's also very anxious to get a glass of wine when we finish here, so we have to work through the signing, whining kind of dilemma. The Irish connection. Obviously, we have to start with John Tyndall, of course, who kind of was the first, I think, really to discern that there is a tendency to accumulate heat at the surface of the planet, and that's the kind of the underlying idea. James' father, Tom, the connection here won't be obvious immediately, but he spent 6 months hard labour in Reading jail for poaching. And this was the same place that Oscar Wilde was incarcerated, so there is this kind of connection. But I think what is interesting is that in the biography I read, this was a source of embarrassment to the family. This was kept hidden. Of course, in that era, an Irish person who had been caught poaching and jailed would be a hero, and this would be the exhibit A in the family, or else we have a kind of a different take on that kind of stuff. His first real connection, though, was a very unhappy one. When he went to school at Letchworth, his first class teacher was Miss Tierney, whom James describes as an embittered Irish woman who liked uniformity and hated a precocious child that had the temerity to have his own ideas. So after many slaps, James was moved on to a woman who has the wonderful name Miss Plumridge, whose name captures what she was like, and he didn't look back. He then ended up at the University of Manchester, and even though he was a Quaker/agnostic, for some reason he joined the Catholic Society. And this was his big opportunity to meet intelligent and attractive Irish girls. And Mary Delahunty became his first love. When I read that, it reminded me of the Lovely Girls competition in Father Ted. For some reason, but the big connection, of course, came in 1965 when he came with his family to Ireland and ended up buying a cottage in Adrigole in the Beara Peninsula. And of course, he started his air measurements there, using the west of Ireland really as a control for his measurements. That the counterpoint, of course, was the UK. And essentially, the instrumentation he developed, the CFC sniffer, really found its first kind of scientific expression in West Cork. And subsequently, his first great book, which really set the stage, Gaia, A New Look at Life on Earth, was written during summers in Adrigole, and he submitted it in 1977 and was published in 1979. And so it was a kind of a product of that atmosphere and age, and kind of opting out that he was able to do this work. So I think we fulfilled our constitutional obligation to make these, I think, rich connections. So my opening question to you, James, is what was the most attractive and interesting feature of Ireland and its society? So that's part A, and part B was what got you annoyed about the place and its people, not including Miss Tierney.
Well, first let me say how very moved I am to be back in Ireland. It's, as you've gathered, it's a place close to my heart, and thank you, Frank, for putting it over so well. I do appreciate it. Well, quite obviously and clearly, you've already stated it. The thing I most loved about Ireland was Mary Delahunty. But there were other things of a lesser order, like Hungry Hill and the Beara Peninsula, which I grew exceedingly fond of, and of its people, and felt very much a part of them. Indeed, I was speaking to Carmel O'Sullivan, one of the daughters of my neighbour, only last night, renewing old memories of the time we had together there on that part of Ireland. Things I hate, not too many really. I think I hated the Troubles because I was there living and working there during all of the worst part of it, really, from about 65 through to 78. So, it was just a pain, that was all. And I think it must have been for you all too. So I don't want to go into that one too much, especially since it's largely resolved now. What was the other question?
Any advice to improve ourselves?
To improve yourselves? Oh no, I wouldn't presume to give you advice on how to improve yourselves. I think, and I'll get into this more later, Ireland probably will turn out to be one of the most favoured nations in the world. And you'd better take care of it. That's the only thing I have to say there.
Okay, let's go on then to your early career. His first job was with a private company, and he learned there the importance of scrupulous accuracy was the term and he contrasted his precision very unfavourably with his fellow students and academics at the University of Manchester later. And I think this was a predisposition. He had to look on the private sector with more warmth and appreciation than perhaps some of his colleagues. He worked then for the National Institute for Medical Research, and this is where I think one of the most exciting parts of his professional personality began to flower, because he realized how important instrumentation was in telling us what's going on, and he obviously had a huge talent in creating that kind of instrumentation. And the combination of radioactive material with instrumentation to tell us things that we didn't know was hugely significant, and it started then, and of course has become very, very relevant, ever more so. He also learned, had a lovely series of vignettes really in his book about working with animals, and one of the nicest things about his professional career is how he was willing to suffer a lot of pain himself in terms of testing materials, because he felt that the animals couldn't handle it as well as he could. So avoiding animal cruelty at that time, I think, was special. I was astonished that he became a specialist in freezing hamsters solidly and then wakening them up from the inside with a special instrument that he developed. And he became a fellow of the Society of Cyrobiology as a result of that and related work. He also developed his well-honed talents, I think, as a lover in that period. He's quoted in the book as making, this is in 1941, I think, making love with a friendly nurse from Guy's Hospital in the first aid room at every opportunity. So he's the living embodiment of Alan Bennett's observation, those who lust last longest. And he also just tucked in his PhD right up in that period. But 57 was the big kind of world path-breaking creation, where he invented the electron capture detector, where essentially one electron is captured for each molecule of pollutant present. There was a lesson from that period as well, which involved essentially taking out the patent when he was in Yale University for that still, state-of-the-art equipment, and not reading the small print, because the provision in Yale was that there was an agreement between the School of Medicine and government bodies that all patents filed from the Yale School became the property of the U.S. Surgeon General's department. So this man is a lot poorer than he might have been if he had. He has tremendous courage, I think, and that's a lesson for all of us. He went out on his own, which at that time was hugely significant, with a portfolio of clients, some from the private sector, which he kept with. And again, he worked for Shell, and I think it's interesting, he's quoted as saying the only people he worked with who actively supported his work on Gaia were the Shell people at that time. And so on. His biggest thing, though, which we'll dwell on later, I think, his biggest lesson for all of us is the fact that he can prioritize. In his recent book, he says the most important question in climate change is how much and how fast the Earth is heating. And he says sea level is the most important indicator. So to distill everything in terms of what's happening down to one variable, he chose CFCs as the indicator of global change. Again, this ability to go from the hugely kind of general confusion to a specific that answers big questions with relatively modest investment. I suppose the question, James, on all of these lessons, when you look at us and the students here especially, in terms of that phase of your work, what lesson do you rate as the most important for students and the research community to take away to have a successful and fulfilling career?
I think the one message I would take from what you said about my early career is the importance, if you're doing science, and probably other things as well, such as economics, to be as hands-on as you possibly can be. We've moved into a world nowadays where the real world is simulated far too much in models and not enough by measurement. If you're a scientist, nature is the final arbiter that decides on the truth or otherwise of what you do. You won't get that from models, or no matter how good the stimulation is. And sadly, they're rarely good at all. And we are being led astray, both, I think, in climate science and possibly also in economics, although I know less about that, by facile models of the world, which do not include enough of the real world in them. Measurement, for some odd reason that I don't understand, is regarded by those who provide the funds as low-class stuff, not worth bothering with. I understand in America, Congress has said that it can't see the point of funding measurements. After all, once you've made them, why measure them? Continue to measure them. And indeed, the Keeling family that were famous for first measuring carbon dioxide growth in the atmosphere on the mountain Mauna Loa had their funds shut off right in the middle of what they're doing by Congress just on those very grounds. Well, now we know what it is. What's the point of continuing? And this, I'm afraid, is something that students coming out from university have got to fight. You've got to try and persuade your politicians. And if you're going to get something from science, measurement is at least as important as the mathematics and the modelling.
Okay. Just following up on that, do you have a particular thought about what data we should prioritise to collect in Ireland?
Well, the one you mentioned, and I'm glad you did, and may I repeat it and emphasise it, is that if you really want to know is the world warming or not, because at the moment you might well have doubts. The global mean temperature hasn't changed much for 10 years. And the last couple of summers in this part of the world have been pretty dire, cool and wet, and not the kind of thing you'd expect of global warming. But if you really want to know what's happening, don't worry about the temperature, because that varies all over the world. We may have had it cool, but the Australians suffered hell down there with drought and heat. Look at the sea level, because there's only two reasons that the ocean increases its volume and rises. One is it's a thermometer. As it gets warmer, it expands, so the sea level rises. The other is that as the world warms, ice on the glaciers everywhere starts melting and runs off into the sea. And those two things are unequivocal measures of global warming. And sea level is rising almost linearly. And about twice as fast as the IPCC in their latest predictions have suggested.
Would you like to dwell on that same idea of a kind of a key indicator in regard to life on Mars, which was kind of your first real eureka moment in regard to the Gaia hypothesis?
Yes, many years ago, it was in the early 1960s, I was invited by NASA, which in those days was only an infant organisation. It was only 3 years after it had been formed. And you may remember it was formed because Congress got itself into a panic over the Russian Sputnik that went up and thought that maybe space is important after all. And my job there was, again, as an instrument maker and designer, and to help them with looking for life on the surface of Mars. What was the surface and what was its nature? But this was kind of subservient to the biological search for life itself, which still goes on, as you may have noticed. It seemed to me at that time that this was all crazy. How on earth can you go and look for life on another planet unless you just assume that it's the same as there is here? And what right have you to assume that? It may be quite different. It may have evolved differently, even if it is there. And you might not recognize it, even if you saw it. So I thought, was there one general way of finding out if there was life on the planet which was independent of any preconceived notions about it? And I read that little book by Erwin Schrödinger, which he wrote here in Dublin, strangely enough, during World War II, called What is Life? Because I thought I might learn something from it, and I did. He said that perhaps the most important characteristic of life is its ability to reduce its entropy whilst excreting entropy to the environment that surrounds it. Entropy is a rotten word and it's complicated, but it implies improving the degree of orderliness. And if you want to get a picture that's better than just those words, think of a sculptor taking a block of limestone and chipping away at it, and gradually there's something beautiful forms, and around him is a hell of a mess of chips of stone and all the rest of it. That's the external excretion of high entropy, whereas the statue is the low entropy. And life's like that. It forms its incredibly intricate shapes and sizes and tends to spread high entropy out into its environment. So I thought, now this will tell us if there's life on a planet, looking for an entropy reduction somewhere in the system, in an unequivocal way. It won't depend on what the life is. It could even be a silicon chip life. It could be almost any kind of life. It'll always be obliged to do that. And so I thought, was there any way you could do it with Mars? And the obvious way was just to analyze its atmosphere chemically. Because if it was a dead planet in equilibrium chemically, you wouldn't be able to get an ounce of energy out of a reaction of any of the gases of the air with each other. But if it was a planet that had life on it, that life would be obliged to use the atmosphere as a source of raw materials and also a place to throw its waste products. And by looking at the composition, you'll be able to tell if that was happening. And sure enough, we soon found out that Mars had almost nothing but carbon dioxide in its atmosphere and was completely at equilibrium and therefore, as far as I was concerned, lifeless, which wasn't popular with my biologist friends at NASA. But when you look back at the Earth, of course, that's totally different. It's wildly out of equilibrium.
Okay, thanks. Just on the same theme of a singular kind of vector, you chose CFC 11 as a kind of indicator of global pollution. Can you explain what your thinking was in doing that and how you set about testing whether it was in existence all over the planet?
Well, it all happened at Adrigole on the north shore of Bantry Bay. One of the queer things I noticed in the summers over there, and that was a long time ago, this would be somewhere towards the end of the 60s, 68 or 69, I've forgotten which. Every so often the air would be very hazy and you couldn't see even the lighthouse in front of where our cottage was, which was about a mile and a half away. And the air looked and smelt like smog, the kind you get in California. And I thought, well, that's impossible. You couldn't get smog right away in the far west of Ireland. It must be something local, some exhalation coming from the bogs or from the sea or something that's doing it. But it occurred every time that the wind blew from the east, never when the wind blew off the Atlantic. And this made me think, I wonder if in fact it really is air pollution coming from Europe, all that way distance. How could I find out? Well, it was no use my looking for sulfur dioxide or ozone or carbon dioxide or any of the typical products of combustion and pollution, because how was I to know they didn't come from some natural source? Or there might be a local cement works not over the next hill that I hadn't seen that was producing it. And then it suddenly occurred to me, there's one unequivocal substance that's only used by humans in big cities, usually, mainly, the CFCs. They're in every refrigerator, and refrigerators leak, and people were using them in those days in spray cans for killing pests, and insecticides, for deodorants, for all sorts of things. So if the air contained those compounds in it, it would be a sure measure that it was coming from Europe, from the great centres of population. And sure enough, when the next haze came, I measured these compounds in the air, and there were 3 times as many with the haze as there were in the clean air that came off the Atlantic. And then, of course, I wondered, well, why is there any at all in the clean air? Where's it coming from? Could it be blowing all the way from the USA? And I realised then the only way to find out would be to go on a ship around the world and measure it everywhere, and that I did.
And can you tell us how that kind of got into the hands of the Californian chemists who kind of analysed the process of breakdown of ozone? I'm not really sure of the exact details of how it got into their hands, but because science is very divided, for no bad reasons at all. Chemists don't speak to biologists much, unless they're brought together, like as I was with them at NASA. And the Californian chemists you're talking of, Sherry Rowlands and Mario Molina, were working on physical chemistry, quite difficult, abstruse stuff, in their laboratory. And they were tasked, I think, also by NASA, to find out if there was any danger to stratospheric ozone from the rockets that were sent up there. And I think they began to realize that the chlorine in the perchlorate of the solid propellant rockets might be a threat to stratospheric ozone. And then somebody must have told them, I think it might have been one of the senior scientists at NOAA, Lester Markter, of the results that I'd got, because I was a friend with his. And it was just the grapevine, really. There was I never met them for quite a long while. They should have included you in the Nobel Prize, in my opinion. But anyway, that's...
Yes.
On your instrumentation, just to finish this piece of our discussion, I know that its extraordinary capacity to measure micro concentrations, and I think I've read that you've expressed misgivings about that, in the sense that sometimes it's abused because DDTs and PCBs and so on are everywhere, and the fact that you find them doesn't mean that they're...
Well, thereby hangs a hell of a tale. The problem always with the ECD, and it's also true of radiation, nuclear radiation detectors, they're exceedingly sensitive. They can pick up amounts of either radiation or chemicals, in the case of the ECD, which are quite infinitesimal and wouldn't hurt anybody at all. And even 1,000,000 times as much still wouldn't hurt anybody at all. But what tends to happen, if some scientist goes out and finds a trace of DDT in the fat of an Antarctic penguin, he will tend, if he's foolish or if the media pick it up, to give the impression that the whole world is absolutely contaminated from end to end with DDT and we're all in danger. Of course, that's nonsense. And it had a very miserable consequence. because it was regarded as serious that you could pick up DDT everywhere around the world, the Americans banned its production and use, and I think they got the UN to join in with it so that it was effectively banned. Now, DDT may be a bad thing for birds when used in excessive quantities in agriculture by farmers, and that was the source of Rachel Carson's book, Silent Spring. But at the same time, the person who invented it was given a Nobel Prize because it was the one substance that had saved more lives than any other that had ever been invented. And the reason it did it, it's almost the perfect cure for malaria, not as a medicine, but in killing the mosquitoes that were... And when used judiciously in malarial regions, not in huge quantities, it cut back malaria almost entirely. And after the ban, that disease has come back and is now killing 2 million people a year, mostly in Africa and Southeast Asia, and making the lives of hundreds of millions utterly miserable as a result of that disease. So you see, I think there's quite a story in the DDT of how being green and being good-intentioned, but not being numerate, can be more disastrous than doing nothing.
Okay, thanks very much. The eureka moment that where you essentially transposed your Mars thinking to our planet, talk us through that.
Oh, well, I remember it well. I was sitting in the Jet Propulsion Laboratory. That's one of NASA's main centers. It's mainly concerned with designing those beautiful little spacecraft that land on planets and look at things. I was sitting in an office there in the Space Science Building that I shared with the astronomer Carl Sagan. And we were both discussing the general life on Mars business, and I was making my pitch that I told you about earlier. And Carl, on the whole, tended to disagree with it. He thought it wouldn't work. When in came to the room came an astronomer carrying a huge pile of paper. And we said, well, what's this? And the astronomer, his name was Lou Kaplan, said, these are the latest results from the Pic du Midi Observatory in France. And what they've discovered there is that both the atmospheres of Mars and Venus are nothing but carbon dioxide and just mere traces of other gases. So that was the moment that I knew that my idea of Mars being lifeless was almost certainly right, because we were all both pretty sure Venus was lifeless, because it's so hot. Too hot for any life to exist on it. I think the surface is hot enough to melt lead. It's that sort of hot. So it then occurred to me, well, if that's so, what about our own atmosphere? It's quite weird compared with Mars and Venus. You've got oxygen in it, you've got methane, which will react with oxygen in sunlight. We knew that already from chemistry. And if you do a quick sum, you can work out that there must be a huge production of both oxygen and methane to keep a steady-state concentration in the air. And we knew already then that it had been pretty steady for a long, long time back in the past. So this made me immediately think, well, something at the surface is regulating the composition of the atmosphere. And then Carl Sagan said, well, regulation might be needed because maybe you don't know, but when life began on the Earth 3.5 billion years ago, the sun was about 25% cooler than it is now. So how was it that the whole planet wasn't completely frozen solid? Or if it was warm enough for life to start, why aren't we boiling now? And then I realized that anything that could regulate the atmosphere, its composition, could regulate the climate. Well, we all know it. We put in CO2 in the atmosphere and look what's happening. We've got problems. So that was quite a eureka moment. I could see this great big system that was regulating both climate and composition. And later, of course, I realized it was doing so in order to sustain habitability.
And then you went on to, you wrote an article in the New Scientist a few years later, which kind of posed the proposition. And then your book, which you wrote in Adrigol, Gaia, A New Look at Life on Earth, you decided to direct that at a popular audience. And by that stage, you'd also gone with Gaia as a label, so to speak. Can you give us a little context for why you decided to essentially not tackle the scientists first, and why you went with the name that you did?
Well, at that time, as well as living in Adrigole, my home in Britain was in a village in Wiltshire, that's southern England, called Bowerchalk. It was not about 12 miles southwest of Salisbury, which some of you may know. And a fellow villager of mine was the novelist William Golding. And at that time, he was not famous at all. He was a school teacher at the local school in Salisbury. And he was a friend, and we would often walk around the village talking about things. And he was originally a physicist. Most people don't know that. They think of him as a literary man entirely. But he trained as a physicist before World War II and only took up writing and history afterwards. Anyway, he was very interested in what I was doing out at JPL, and I told him about this idea of the Earth self-regulating. He said, well, Jim, if you're going to come up with a large theory like that, you better have a proper name for it. So I said, well, what would you suggest? And he said, I'd suggest Gaia. And we walked on for 20 minutes talking at total cross purposes, because I thought he meant G-Y-R-E, you know, on those great worlds in the ocean which do self-regulate. Bill said, no, I mean Gaia, the Greek goddess of the earth. And, well, when you're offered a name by a wordsmith as famous and competent as that, you don't turn it down, do you?
Okay, and the second part of the question was you decided to go for a popular audience for your first book rather than do a kind of a scientific piece. You obviously had a plan in your head on that.
No, I didn't. It was much simpler than that. All through my scientific career, up until about 1963, any paper I published, any paper I wrote, scientific paper, would be published by the journals. I sent it in, it'd be sent out for peer review, and everything was all right, and they published it. Almost none of them ever bounced. And then the biologists got a hate thing about Gaia, which it was called then, and they were so influential that it was impossible to publish a paper anywhere in any journal. It was almost like a censorship. And I realized then that there was no way I was going to get further ideas on it out except by a book. Now, it was no use my writing an academic textbook, because that would be censored in much the same way as the papers were. So I thought, well, it's got to be a book that would be acceptable to a regular publisher. And so that was it. Although I did have an academic publisher for the first book, Oxford University Press, who took it quite willingly. But you've no idea how strong the censorship was in those days. The first model we made of Gaia, called Daisy World, I made with my graduate student Andrew Watson at the time. It was rejected immediately by Nature, although the editor came back from a holiday, that was John Maddox, several weeks later, and wrote to me personally saying that if ever there was another Gaia paper, send it to him personally, not to the journal itself, and he would make sure it was published. And he honoured that obligation in 1987 when we had a paper on the dimethyl sulfide emissions from the oceans.
And I know that Richard Dawkins took huge exception to. He was I think you mentioned somewhere that he was the leader of the biologists who essentially, the evolutionary biologists who objected to your propositions.
Well, Frank, I don't think he was actually the leader. Richard Dawkins is a very talented author, as you well know. And he's less well known for the science he did. I don't mean he wasn't a scientist, but he's not famous for his science. He's more famous for his writing. Now, the lead biologists in Britain at that time were John Maynard Smith was one, and another was William Hamilton. And the third one was Robert May, who subsequently became president of the Royal Society. So they were all pretty heavyweight bunch. And they were convinced that Gaia was not only wrong, but was positively dangerous to science, a bad, harmful idea almost. It was a heresy, if you like. Because the reason they had this view was they'd spent an awful lot of time finally settling the business. Did evolution occur through single organisms, or did it occur through groups, called group selection? And they saw Gaia as just group selection, even larger and made popular, and therefore dangerous. John Maynard Smith called it an evil religion, which gives an idea. Now, they set Richard Dawkins as a Rottweiler to destroy it, and he did a damn good job.
Okay. And then your next book was a kind of a riposte, in a way.
It was an attempt at a riposte, yes. But it didn't work.
Okay.
And it wasn't until the mid-1990s that they began to come round, and it wasn't until 2001 that scientists held a meeting in Amsterdam and issued the Amsterdam Declaration that stated the Earth is a self-regulating system made up of the atmosphere, the oceans, the surface rocks, and all life, including humans. And that was when they came round.
That was the breakthrough, was it?
That was the breakthrough.
Okay.
That was a long time ago.
Okay.
Well, a fair time ago.
The Revenge of Gaia, then, in 2006, was a fairly polemical piece, I guess, where you essentially pulled all the IPCC evidence together to tell a story. And that's really where you developed this idea of positive feedback as a very powerful negative force. And as we were saying earlier, when you give a child positive feedback, it's a good thing, we assume, but in the world of Gaia, it's a very bad thing. So it might explain what it means and why it's malign in its outcomes.
Well, if you'll forgive me, Frank, I'll have to go into a little bit into the background. Positive feedback is a term that's used in systems engineering. For example, if you make an autopilot for an aeroplane, it's got to have what's called negative feedback and positive feedback. If the plane strays away from its course, which is kind of been set in the thing, then negative feedback gradually draws it too. But if it's strayed a little too far, you've got to bring it back quickly, or it might do something bad, like dive in the ground. And that's where you need positive feedback to make a rapid and effective response. And we all have it in our bodies. When you move your hand out to pick up something, there's negative and positive feedback operating in your muscles, so the movement is smooth and controlled, and not a jerk that knocks for example, the bottle over. The best way of sort of thinking of positive feedback, because this term's going to keep coming up in global warming affairs, because the Earth is seriously in positive feedback at the moment with respect to heating. The best way to think of it is imagine that you're in a log cabin somewhere a long way up on a mountain, if you like, and it's darn cold, and you find a huge pile of logs and stuff and light a great big fire in the fireplace, but you overdo it, and it gets so hot that the furniture in the room starts smouldering. Within minutes, the whole log cabin will be gone, because positive feedback is part of the whole process of inflammation, and you see it in operation.
So can you give a few positive feedbacks in the global Gaia context?
Sure. Well, you probably all heard not last summer, but the one before, about all that ice that melted in the floating ice near the North Pole. So much melted that I think there was only about 40% of what is normally there was left. Now, ice that was floating in the North Pole covered the whole of the Arctic Ocean up until about 1986, completely. And every summer the sun shone in it, and the sunlight was reflected straight back into space. Now, when that ice started melting, it exposed dark, black, almost black sea, and the sunlight coming in was 80% of it was absorbed by the ocean, which rapidly warmed. That melted more ice. There you have positive feedback. The more ice that's melted, the more seas exposed, the more heat is absorbed. And it's a very serious business. We reckon that in any time between 10 and 30 years, all that floating ice in the North Polar regions will be gone in the summer. And when that happens, the amount of heat absorbed during the polar summer will be equal to the amount of heat we've added to the atmosphere by adding CO2. So in a sense, the Earth is already joining in the act of global warming, and in a massive way. And that's only one of about 5 major positive feedbacks that are happening now at this very moment. The others are the melting of the permafrost in Canada and Siberia is letting out CO2 and methane and other gases to the atmosphere and adding to the greenhouse. The more it melts, the more it happens. Another one, which is very important, you hardly ever hear about, is that algae can only live well in the ocean if the water temperature is below 14 Celsius, quite fairly low. And the reason for that is that if it gets above 12 to 14, the top layer stratifies, floats on the surface as warm water. So nutrients which are in the deeper water can't get into it. So the little floating algae use up all the nutrients, and then there's no more can grow. So this is why the tropical oceans are clear and blue and delightful to swim in. And you can see right the way down 100 meters or so, whereas the Arctic waters, which are cool, are almost like soup. They're full of life. Now, the warmer it gets, the more of the ocean that is stratified with no life in it. So the ocean is becoming a desert everywhere, and the warmer it gets, the more it becomes a desert. And that's truly important in global warming. I won't go into all the rest, but they're all there.
Okay, let's turn to the kind of final section just to talk about solutions, which you dwell on quite a bit in your book. And an area that I haven't read much about myself, and you go into quite some detail, is the whole geoengineering area and the choices that exist there. Would you like to just talk about what your prime candidate for geoengineering might be?
Well, I think one ought to mention that we've been geoengineering, in a sense, right from the time we discovered and started using fire to burn down forests to get cheap cooked meat, I think was the first thing we did. And then we discovered that if you cleared the forest, you could turn it into farmland. And that started us on our road down, I think. And that was geoengineering, in a way. Use of technology unwisely. Now, for our present threats of global warming, it's natural for scientists everywhere to say, gee, well, we could fix it, especially if you're American. And it's a matter of technology. Well, to an extent, they're right. And there are several geoengineering ideas put forth. We know, for example, that when a big volcano goes off, it blasts a lot of sulfur dioxide into the stratosphere. When Pinatubo, the volcano in the Philippines, erupted in 1991, it put 20 million tons of sulfur dioxide in the stratosphere. That's not an awful lot as an engineering thing, 20 million tons. So, and that stopped global warming dead for 3 years. So there's a lot of feeling, well, if we just get that sulfur dioxide up there, then we could call a halt to global warming. And I think they're right. It's not the only way of doing it. There's some people have the idea of just spraying seawater all over the ocean in little automated things that float on the surface, and producing what's called a marine stratus cloud. That's low-lying clouds near the ocean surface. They would reflect sunlight back to space just as well as the sulfur dioxide stuff up in the stratosphere. Those things probably will work. But the problem is, they're really a bit like if one of you is so unfortunate as to have your kidneys fail, you can always go on a dialysis machine, which will keep you alive a few more years. But it's not a cure. It only buys you time, and that's all these things do, because for 2 reasons. Firstly, the Earth is heating by itself now, regardless of what we do. forgotten what the second reason is, but never mind. But the point is, they're not a cure in themselves.
Well, also we keep emitting, I suppose.
Yes,
So
well, that's right. And the point is, the CO2 that's building up does other damage, particularly to the ocean. It makes it too acid, and ocean life dies off, even in the polar regions where it's cool enough.
In terms of your kind of preferred choices well, geo isn't a preferred choice, but it's certainly you're proposing that we take it seriously as an interim option, I guess.
Well, if you really want to get geoengineering working, and to use a phrase I hate, save the planet, I don't think we can. It's not our job to try. It's looked after itself for 3.5 billion years, and we ought to trust it to continue to do so. No, if you really want to do something useful, I think a suggestion made by a scientist in New York some time ago called Johannes Lehmann probably has the best option. And that is to do what Amazonian Indians have been doing for years, and that's turn farm waste into charcoal and bury it in the soil. The Indians do it because they think it improves the soil. It doesn't seem to do any harm anyway. And my vision is quite a simple method. You would have farmers everywhere given a small charcoal maker that would also accidentally, as a byproduct, produce some biofuel. But the main thing it would do would take all of the ag waste, the straw and whatnot, that's not used much, because we just take the grain and use that, and convert it to charcoal. Charcoal's a bit like gold. It's totally indestructible. It can't be biodegraded. Neither does it react with oxygen. Just stays there forever. Now that is massively taking carbon from the atmosphere, and Gaia does it for us. Because as the plants grow, they pull out CO2 without any effort. We don't have to join in the game at all. And it's sort of joining in with Gaia rather than doing a pure technology job. Moreover, I think that if that carbon burial scheme really worked, it wouldn't require subsidies. Farmers would just do it on the profit they got from selling the biofuel that came as a byproduct. And I think that's the way with the greatest hope, really.
Okay, a second choice that you are quoted as supporting is nuclear power. And you say, I've always seen nuclear energy as a force more for good than for harm. And you have this wonderful quote where you say, if all the nuclear weapons stockpiled on Earth were exploded almost simultaneously, there would be detrimental effects on us and the large mammals and plants, but it is doubtful whether unicellular life would, for the most part, even notice. So this is good for unicellular life.
Well, I hope nobody's intending to do the experiment.
Okay. Anyway, would you like to talk through your view on nuclear?
Well, I think I'm much misunderstood on this topic. I've worked with radiation, or radioactive materials all my life. You better ask Sandy. I don't know whether I glow in the dark. But I wouldn't be surprised if I did. But also bear in mind I'll be 90 in July, so it obviously hasn't done me very much harm. I feel strongly on this topic because of the country I live in, Britain. We're grossly overpopulated. We're running at about 60 millions now. You're so lucky in Ireland, you've got about, a tenth the population per land area that we have. But anyway, we're grossly overpopulated, which means we're city dwellers. 95% of the people of Britain live in cities. And as a consequence, they're utterly dependent on a constant, reliable supply of electricity. See, a city like London would become like one of those camps in Darfur within a week if you shut off the electricity altogether. You see, it's not just the lights that go out. Nothing works. The sewage, the water supplies, the fuel for cars and things, everything depends on electricity for its control and operation. And the fridges in the supermarkets, the whole damn lot. It would be the most unbelievable mess within a week without it. Now, how are you going to get the electricity without putting carbon dioxide in the air? And don't tell me, as the Greens do, you could use renewables, because we know they will not do it. The Germans, as was said in Der Spiegel only 3 weeks ago, have more wind turbines than almost anybody else. And they're now finding they're emitting more CO2 since they put them up than they did before. The reason's quite simple. The wind turbines only work on average effectively, as far as producing electricity goes, about 17% of the time. And so they have to make up the remaining 83% by burning coal in East German power stations, which are not particularly efficient. So the net effect is an increase of CO2, not a decrease. So I don't think we're going to, we certainly couldn't feed the cities of Britain with renewable energy. The only option really open to us is nuclear. Now that is obviously patently not true of Ireland, but it's certainly true of our country. So that's really why I support it. It's horses for courses. If you live in Iceland, you don't need anything like that because you've got geothermal energy. If you live in Norway, there's plenty of hydroelectricity, and so on. It's each nation has got to treat the energy problem according to its own needs, and I think we have no option but nuclear.
Do you have a view just on the renewables? I mean, this intermittency problem, of course, is inherent in a lot of renewables. Presumably, if there was a breakthrough on storage of electricity, for example, that would change the equation somewhat.
It would help enormously if there was a good, reliable way of storing electricity. But I don't think it would be prudent to wait around until we have one, because people always forget it takes about 40 years from the invention of something to its widespread use on a grand scale for everyone. I mean, you think of all sorts of things, computers, aeroplanes, everything. It's an awful long way between the Wright brothers and you taking a seat on Ryanair, a very long way. And it's too easy to collapse that down and imagine that a storage scheme is going to be there available and you can just use it. You can't. It takes time, even with the best will in the world.
And just on the nuclear one, I suppose a question is whether, I suppose you could make a proposition that every country that wants to become a nuclear power uses nuclear power as a kind of fig leaf on the way to weaponry. Is that a danger, do you think?
I don't think so. You see, why I'm misunderstood here is there's not much doubt from both America and Europe that we could get nearly all the electricity we needed in not too long a time by using what's called solar thermal energy. In America, for example, they work out if they had 10,000 square miles of Arizona, which is only a small proportion of that single state, covered with steam generators running off solar sunlight during the daytime, that would supply the whole of North America with electricity. And they can cope with the intermittency problem by using steam accumulators that will store the steam produced in these overnight. Well, it'll take quite a time to implement that sort of thing, but I think it's already being quite seriously considered. And Europe could do it using southern Spain, and the Sahara, of course, would be even better. But it's not immediately available, and it's not much use to a country like Britain, which is a long way away from that, or from that kind of solar energy. You could have steam generators here, but they wouldn't be economic.
So it's kind of a time phasing thing. I mean, long term, you do see solar as the solution.
Yes, it is. Timing is the essence of it all.
Okay. You reserve particular vehemence, I think, for biofuels as a non-solution or big problem and so on. Would you like to elaborate on that?
I would, and I think you have to bear in mind a background to this. Some of the countries of Northern Europe, Germany and Denmark in particular, decided a long time ago that they would make a big business out of being green, of having renewable energy schemes and things like that. And amongst those were, of course, wind turbines we know all about, of which they built up a huge industry making. And then there was biofuels, which the German chemical industry has made quite an effort into turning into a practical proposition. Now, this is quite laudable, and the EU agreed to have the renewables obligation, as they called it, to make the rest of us pay for this development and buy the products. So we're tied into biofuels and windmills, whether we like them or not. I think this was a big mistake, and I think it was premature. I think, like all things, it was done with good intentions. But as we all know, the road to hell is paved with good intentions. And in the nature of global warming, it could be all too true.
And do you include bioheat in that kind of condemnation, or are we talking about biofuel for transport? What's your thing about, say, using wood chips for heat? House heating?
It's awfully difficult to be hard and fast about these things. For example, in your case in Ireland, I think the feeling against nuclear is such you'd never use it. And perhaps whether you should or not, I don't know. It's not my business to tell you what to do. But I think you should bear in mind the really important thing about Ireland is that it is a lifeboat for humanity. It's almost certain to be the least affected nation in the world, apart from New Zealand and a few other island places, by global warming. And therefore it'll be a place people will survive on and carry on humans into the future. Now, I don't think you should therefore worry too much about how you get your energy. I can't see it would really make a hill of beans of difference if you went on burning fossil fuel to the world. I mean, and the idea of it setting an example, I think, is completely trumped by the need to let people have a safe haven where they can survive. It's almost like telling the captain of a lifeboat, oh, you can't run the engine, it spoils our carbon footprint. I mean, it's just a lot of nonsense.
Okay, I think that's a good note to... Now the floor is open for questions, and we have mics here. So if you could come up to the front, if you wouldn't mind. Do you mind coming up to the mic, please? Yeah. And if you could just introduce yourself and be brief. Thank you.
Yeah, my name is Paul O'Brien. Thank you for your wonderful talk. Will we need nuclear weapons to keep people from boarding the lifeboat?
I think that would be overkill. But you will need weapons, I'm afraid. People will want to come here. They're already coming to Britain, and we're overcrowded. I think it's inevitable that, you see, the same class of thing happened 55 million years ago when a huge amount of carbon dioxide went into the atmosphere from some natural cause, not well known, but temperatures rose enormously. The polar regions got so warm that there were crocodiles swimming in the North Polar Ocean, and you can find their remains in the fossil record. And these sorts of latitudes in Europe were tropical forests and that kind of thing. So it's happened before, and during that time, life migrated to those polar regions, and that's why there was no great extinction. Of course, when it cooled off again, they were able to go back and recolonize the Earth. And the same thing is already happening. You're seeing it with with things other than people. They're moving as the climate warms up.
Okay, next question. Yep.
Just a quick follow-up. Are we going to run out of uranium?
Are we?
Are we going to run out of uranium?
No. And there's even more thorium, which works just as well.
Okay, thank you very much. Okay, you
yes,
first.
Steve Conkle, and I would like to thank you for the wonderful opportunity to just listen to the stories and understand things better. I me, it's great. I've been over here as a Fulbright scholar for a year working in Ireland, and I'm very interested in improving the scientific basis of environmental decision making. There are institutions in the United States like the National Council on Science and the Environment that have been tackling things like climate change and other things, and there is a politicization, I guess is what you call politics. Sometimes if you already know the right answer, you go after the scientists that are going to support your policy positions. My question is, and one of the things that was somewhat disturbing about what you said, is given the importance of system thinking and choosing the right indicators, like CFCs for problems like global warming, how likely is it that the traditional scientific peer review process can be reformed in a way to enlarge it so the scope of the problems is appropriate, the methods and the discussion and the debate is allowed to take place, and it can withstand the political attacks from people that already know the right answers, and therefore the science is totally irrelevant to them? Thank you.
Thank you for that very relevant question. I think you put your finger on a truly important point there. Because science is so divided, it's becoming almost impossible to conduct it properly. At the last count, I found there were over 30 different branches of biology. And some of the members of different branches are almost proud that they know nothing about the other branches of biology. Still less do they worry about not knowing anything about chemistry, physics, mathematics, or anything else. And this is a terrible state of affairs. And it's not just biology. There's probably as many branches of physics that are in the same kind of thing. And we can't help it. It's a sort of Paris process that's gone on ever since science started. And the universities don't help it. They encourage the development of departments so they can have more professors.
There are a few exceptions to that, of course.
Well, but it's something that has to be taken seriously. And all I would say, and I'm prejudiced, is I think more scientists should go and work on their own outside it, because it's very easy once you're outside the sort of disciplinary area to work on anything you like. You just have to be more ingenious.
Okay, thank you.
Yes, my name is Convery. I'm an ex-professor of this institution here. When I read your first book, Gaia, I was somewhat surprised to find you made very little reference to population. Now, we're facing, in the present time, we have probably an increase in our population of 80 million people every year. And we have a world population where I think close to half the population in the world is under 25 years. Mm-hmm. Are we in cloud cuckoo land when we talk about climate warming and means of reversing the present degradation of our environment without referring to climate? Is it possible that with a population which is grossly in excess of what the planet can now bear, are we really in cloud cuckoo land when we talk about things like solar energy and so very important things that you mentioned?
Well, I hope you're wrong, but I think you're right, is what I would say to that. Yes, it's not so much the population at present, but the way we live. We are living at an excessive rate, but we don't have much option, because the Earth could support a population of not probably much more than 100 million, if that many, as hunter-gatherers, as we were back originally. It couldn't possibly support the population there is at present. So we had to farm to push the numbers up. And then when we industrialized, they went up even further. And we were getting further and further away from a practical possible solution. So there's only two answers. We'll either be driven back by Gaia to being hunter-gatherers, just a few breeding pairs dotted around the Arctic Ocean, that's warm. That's a grim picture. Or we'll be a much reduced high-tech civilization living sensibly with the Earth. I don't think there's any state in between. But the reduction in numbers is likely to be huge if global warming proceeds as it's predicted to proceed this century.
We might solve our problems despite an increasing population up to, say, 8-9 million.
We're not going to solve the problem of keeping the present numbers alive. No, I don't think we could ever do that.
Just following up on that, oh yeah, okay, go ahead, go ahead.
I'm going on to something different though, Frank. Yeah. Thank you very much indeed, James. I really enjoyed the talk, and I really have great admiration for your courage in stating things as well, which might not be popular with some people. My comment really is a comment, first of all, and the question is in connection with Sherry Rowland, who you mentioned about the Nobel Prize. And of course, he's always said, I'm just an academic working in the laboratory, but of course he was doing the measurements, which then made the proof so much possible. And of course, the world has done it before, as it were. It was a simpler problem to solve because, as you say, only 6 industries were involved in the production of CFCs. One other thing which you perhaps have noticed as well is that he said that there were 3 Nobel Prizes at that time, Paul Crutzen and Malina, and Malina was the graduate student. And there are a lot of graduate students here, so I hope that there are lots of potential Nobel Prizes as well coming from the work that's being done here. Sherry Rowland is coming here, by the way, next month. He's giving a lecture, and I hope many of the people here who've come here will come along and hear Sherry Rowland as well, because he's an impressive academic. Now, I heard him in Kyoto recently, and there was one line that he said, and I'm going to ask him that question, and I'm going to ask you as well. What he said was that for some reason or other, methane doesn't appear to be increasing in the atmosphere. Just a line, and that's extremely important, not only from Ireland, because we have a lot of animals in Ireland, much more animals than humans in Ireland, so it's important from our point of view. And of course, as you mentioned, there's an incredible amount of methane which is trapped in the ice, which could
that's right.
So I was sort of listening to you, and you were talking about carbon dioxide rather than methane. I don't have expertise in the area, and I just wonder where the methane is going.
Oh, I agree with you absolutely. Methane is a vitally important gas in the greenhouse equation, and it could become rapidly more so as time goes on. To put it in perspective, if you have a leak of just 1% in the natural gas pipelines going somewhere or other, its effect on the atmosphere is something like 20 times greater than the CO2 that the burning of the natural gas produces. One tends to ignore it. But you brought up Mario Molina a couple of times, and I think by sheer coincidence, I was sitting next to a gentleman at a meeting in Paris last year, and he turned to me and said, I know you, don't I? And I said, yes, I feel in the same way about you. He said, well, I'm Mario Molina. I said, well, I'm Jim Lovelock. And then we started talking, and the one thing he said that really impressed me was, what a pity there aren't just 6 large industries making carbon dioxide. How easy the problem will be to solve. Because it's all of us.
I just want to go back to what somebody else said previously about the population. In 2009, we have 6.5 billion population. And in 2050, they project it to be 9 billion. And by 2100, possible 12 billion people on the planet. With a sea level rise, as you were mentioning earlier on, by 2050 of about half a metre, and by 2100 of about 1 metre, with all the mass migration that will have to occur from the cities that are below the sea level or at sea level that will occur. But there was a newspaper report this morning that mentioned yourself that you said by 2100 there'd only be 1 billion people because of the desertification on the planet. Now, I don't know if that newspaper report is correct or if that was from yourself or not. But that's there'd be 1 billion people left. So if you take it that in 2009 with 5% arable land, And in 2050, for a population of 9 billion, you'd need an extra 2.5% arable land. And in 2100, you'd need an extra 5%, which would make 10% of all arable land for 12 billion people. Is that a possibility for this Earth? But you mentioned also that the Earth was a self-regulating system with the atmosphere, the rocks, soil, and all life contributing towards it. But surely to goodness, the human race is a self-regulating system. And we just need water, food, and shelter. And if you have 2,100, if you have 1 billion people, you're saying we're going to survive. Or if, projected model, 2,100, we have 12 billion people to survive. In your model of the 6.5 billion to 1 billion, what time frame are we talking about? Are you saying we'll have 1 billion by 2050 or 2100? And what are we going to do with the 5 billion that won't survive?
I take it the question was the last one. Yes. No, I wasn't. I doubt whether that's exactly what I said, although the newspaper reporter that was interviewing me at the time, I'm sure thought that was what I said. In no way do I wish to suggest it was a distortion. I wouldn't give an accurate figure like there will be only 1 billion people by 2100. What I meant to say, really, was if you wanted me to give a guess as to how many will survive to that time, it would be in the order of 1 billion, which is a very different thing. I mean, because plus or minus what? It's a scientist's answer. But what will happen to them, of course, is they will die sooner than they would have done otherwise. It's a reduction of lifespan is a better way of looking at it, rather than actually.
Is it 2050 or 2100?
What for 1 billion? Now 2100 was what I had in mind. But do remember that all of these forecasts, way down the tracks, 2050 or 2100, are to a large extent moonshine. We don't really know. There are a few things we can be fairly sure of. Is from the Earth's history, we know if the CO2 rises to something in the order of 500 to 600 parts per million, we can expect global temperatures will rise along with them, because the two quantities track together very, very well in the historical record. And then we can make assumptions about what the world will be like. But it is very much guesswork. And politicians are very foolish to pass laws about what we should do now to change things that are going to happen at 2050 or 2100. We don't know enough about the system yet.
Thank you. You're very welcome back to Ireland, Dr. Lovelock. It's good to see you here. I read the same article that the gentleman referred to, and it did surprise me that in the time that you've been alive, the world would be so dramatically changed. But in terms of what you were saying about the heat absorption in the Arctic areas, I can well see the plausibility of your theory. Just to let you know, one piece of information I read, or one statistician calculated that there's only the level of fresh water available is only sufficient to support 9 billion people. I don't know if that enters into your calculations. So indeed, the bottles of water in front of you could be something very common in a few decades' time. Just in terms of population, I remember when I was young growing up, they were saying that the population was 4.5 billion, and it's already increased by 2, which was the population only of the entire planet only 100 years ago. So it is a case, just I mentioned that because it's an example of the extraordinary surge of growth and extraordinary levels of growth across the world. And I can tell that you have an interest in economics as well, and I'm just wondering what your opinion would be in the way that the economic system over the past even 150 and not just 50 years has focused on profitability rather than productivity and profitability gains, which of course are reliant on a growing market, which is reliant on a growing population. And I'm just wondering if, in your opinion, that we as a global economy and global society are in fact possibly addicted to growth, which is the very thing in the feedback loop you mentioned is endangering us. And is there a cure for that addiction?
My goodness, that's a difficult one. In a long lifetime, I've learned that one thing you can almost rely on is that predictions 50 years ahead are horribly wrong. I remember being asked by Lord Rothschild of Shell in 1965 to say what I thought 2000 would be like. He was concerned for his company, of course. And I remember the reply I gave, which was quite different from the usual one, was that by 2000 the main problems that Shell would be having were environmental ones, but they would nevertheless be making a profit. But it's the answers are more like that, I think, looking ahead. One always underestimates human ingenuity and changes in solving things in ways that you would never ever have dreamt of. I mean, the eruption of the mobile phone, I think, is an example of something that has changed so much, so many people in so many ways. In Africa, for example, it's almost changed the whole landscape in a way. People are networking, doing their things by mobile telephones long before any copper wires were laid down. And it's things like that you can't really predict happening that make these future predictions. And remember, most of all, the IPCC, 1,000 of the world's best climate scientists, have got it so disastrously wrong in predicting what the sea level would rise to date. They're wrong by 100% on that one.
Okay, we're going to bring things to a close shortly. So we have how many here? One, just two. Okay, so two here, three here. So can we be very... Can we all be very, very brief, okay? And then how many on this side? Three, okay. 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 We could be here all night, but we'll... So I'll take the next two together, okay? And then we'll go to James for a composite answer, okay? So the two of you there first, okay?
Paddy Allen, right? Mentioned that nuclear energy would be, or do you think might be necessary for the UK? Is that coupled with, or does it have to be coupled with a change in the way we live in the current industrial society?
Okay, thank you. Okay, second one.
I'm Anuradha. I teach Sanskrit in the School of Philosophy. I had two very naive questions. The first one was, what is the role of trees, planting trees and all in helping in this whole pollution business and all of that thing? And the second one was that if one looks at the whole Earth in terms of vibrations, we are trying to change, let's say, chemical compositions in the Earth's atmosphere by adding other chemical other chemicals to it, etc., and we are worried about that. Could we not think of doing something like maybe sounds, like changing chemical compositions with the help of sound or light or something on those lines?
Okay, so you have a nuclear life change and sounds and light change as an intervention.
Well, I think I'll tackle the second one first, but since we don't have long, it's often thought that planting trees is a good thing. Well, I planted 20,000 of them about 30 years ago, and I now realize it was a grave mistake. I should never have done it. What I should have done is to let the land just be as it is and produce its own trees. You see, you can't plant an ecosystem, you can plant trees, but with a world that's changing, with global warming, you would never know what trees to plant, would you? Because by the time 30 to 50 years have passed, those trees may be quite the wrong ones to be there. Whereas if you leave the land naturally, it will evolve. And an ecosystem is made up not just of trees, but of everything from bacteria in the soil, worms, small animals, plants, small plants, everything. Just plant a plantation. That's not what's needed. The nuclear one was, I can't quite remember. It was...
I think there was a combined question. If we go for nuclear, does it imply also a lifestyle change, or should that accompany it?
I think it would almost be the other way round. If the people in Britain don't go for nuclear, there will be a huge lifestyle change. If they want to continue their city life, more or less with things running and the television showing the usual shows, they'd better go for nuclear. They don't have much chance otherwise.
And the use of light and sound as a way of changing the atmosphere rather than your suggestions?
It's an intriguing idea, but I'd need to know more about the technical details because I can't see offhand how it would work.
Okay, we'll take two here. Together.
Hello, yeah, I suppose fellow scientist, I bow to you in respect. And I suppose my favourite thing about being a scientist is when people ask me, why do I like to be a scientist? Mostly children ask me. Say, my favourite thing is that none of us are ever right, none of us are ever wrong. And I think that that's the best thing about studying the science field, is that you're never quite right in one area, you're never quite wrong, because it's all the time changing, and it's progressing in what we think is planet Earth is flat, and I know it's flat, as they said in the Blackadder, and I know it's flat because I walked it. But now we've proved that it's round, and I think a lot of theories you put forward are very influential, but yet you kind of have the attitude, I suppose, with the trees. Why bother planting them when we don't know what it's going to be like in the future? So I think with someone that has such influence, would you not press more forward as opposed to going nuclear, that maybe the British should take a lifestyle change as opposed to sitting in front of the television? Because nuclear power is kind of like giving a monkey a grenade. You never quite know what it's going to do with it. And we shouldn't leave that problem for children to look after.
Well, I think you speak for the feelings of Ireland on this subject. I almost wholly disagree. I wouldn't say it suits everybody, as I said earlier, but it's dangerous. They've been so grossly overplayed that they're just nonsense. You see, just to give you one single statistic, I could go on all evening, and I'm not going to. The nuclear industry in Britain has existed now for over 50 years. There hasn't been a single death in it, nor even a single person injured. You can't say that of any other energy industry, even renewables.
And what's the half-life of nuclear waste?
About 600 years. The half-life of CO2, incidentally, is also quite long.
Okay, another one here.
Yeah, my name's Paul Barry. Just wanted to revisit a remark you made towards the end there again about, Ireland shouldn't bother trying to set an example, as regards, moving away from fossil fuels. That might have been an off-the-cuff remark.
It wasn't.
I think we can set an example. I also think we need to worry about energy independence, which we have a serious problem with in this country, and also maybe about the global political situation that would arise, were we to become this lifeboat nation. Could you maybe comment again on that? It just didn't seem to me to be the wisest remark. Thank you.
You are absolutely right to take me to task for making interfering with the way you run your country. What I was thinking of was that I see Ireland in the long-term sense as being one of the lifeboats, as I've said, more than anything. So its imperative is to survive and run itself in a way that gives the people here and any that you welcome in, and you'll have to welcome in some, a chance of surviving on into the future. And I think the issue of what energy system you use, or whether you add CO2 to the atmosphere, is almost trivial compared with the importance of survival.
Okay, we'll take...
My name is Vanessa O'Connell. Just a question I have. Malthus, a well-known economist, said back in the 17th century that we'd all die of mass starvation because we didn't have enough land to feed the world. But then what we have is technology, and we've increased yield, and we've been able to support the population that we have today. Do you not think that we need to remain optimistic, that we have the ability, human beings have the ability to solve this problem, like we've solved problems before? And what we may need is a mass shift in behaviour, but we have to focus, like looking to the Copenhagen, the new global deal, that we have to focus that we can have the ability to solve this problem and that the population will be able to survive with us.
I'm an optimist, I think is the answer, but I'm an optimist for humans in the long term. I think we're a very tough animal and we'll survive, and we've probably got a very great future ahead. But I don't think that just now we are clever enough to handle the problems of the world. In fact, I've often said the worst fate that could ever befall people of the present world would be to have to take charge of running the atmosphere and the composition of the earth in the way that Gaia's done. It would be a ghastly task, and we wouldn't manage it. Would any of you trust the United Nations to control the level of the oxygen in the atmosphere? I wouldn't.
Okay.
My name is Charles Tansworth, Chairman of Antarctica. We run the Green Schools in this country, which is probably one of the most successful Green Schools programs in the world. And one of the reasons is to give the next generation some chance. And I go to presentations, and all I can think of to say to the next generations is to apologize for what my generation has done. Do you have any more hopeful thoughts that we could give to the next generation?
Oh, heavens. I don't think it's helpful for us to feel guilty about what we've done. We seem to get into a terrible mess. For example, if the carbon dioxide goes up in the air, we blame the energy companies, the oil companies and the coal companies and so on. We always forget we do it ourselves. But we don't do it ourselves just to be perverse, to destroy the atmosphere. We do it because there are so many of us that we have to, and we need the energy to get to work. It's not our fault that we drive cars to work. The cities have evolved that way. I think blame and guilt are not really helpful in the context of the problem that lies before us. I think, again, and I repeat it, the most important thing is to survive, to carry on our species. And that's our imperative and our proper task.
Okay, we'll take two together here, okay?
Hi, my name is Molly Walsh, and I'm a graduate of one of the many kinds of biological science that you mentioned here at UCD, so it's a real pleasure to see you speak here. My question has two parts. One is that you're kind of well known for advocating nuclear power as a solution. But I wonder, in fact, might you advocate people power as a kind of solution? Even Al Gore is now advocating civil disobedience in the face of climate change. And I think when a politician from Tennessee tells us that he doesn't understand why there aren't more young people sitting in front of the bulldozers, it's time to pay attention to that. In particular, he was talking about coal and new coal-fired power stations. In Ireland, we burn peat of all the stupid things to do. And also, I would ask you, do you have any advice for those of us campaigning in any way that we can to turn the ship around, whether we were lucky enough to be born in the lifeboat or not?
Can you hold that? Okay, next. Yep.
How are you doing, James? Thanks very much for tonight. Dave Kiernan is my name. I'm a layman. I must congratulate you on the three words: population, population, population. Which our Green, I've been involved in the Greens since I started. The only reason I've been involved is it would ever bring up population, overpopulation as a problem in this country. You're talking about England being overpopulated. Well, if we hadn't got the famine, mass migration, because we love our big families in this country, but we did until the money started running out. And we could easily have 40, 50 million people in this country if we didn't have the safety valves of migration, emigration, you name it. Do you not think that humanity, certainly over the last 200 years, should be ashamed of itself? Global humanity, all 8 billion of us, or 6 billion, whatever it is, doesn't make much difference, I think, once it goes over the 100 billion mark. For the fact that we've ravaged every wilderness area, nearly destroyed most other plant and animal species, and should we not be ashamed of what we've done for the last two or 300 years? And it's only the last 200 or 300 years it's happened because purely population pressure. Population, population, population.
Well, I suppose we are not all that different from any other animal species. It's well known in biology if a species of organisms increases in numbers and goes beyond its carrying capacity, it's bound to crash. And it seems that we're behaving in many ways just like any other animals, but I don't think any of those animals that face that, be they rabbits, for example, or sheep or something, ever feel guilty about it. And this is what I feel we shouldn't be doing. We are just doomed to be participants in a natural evolutionary event. But our imperative, I keep saying this, I'm sorry to be boring, is to survive. We mustn't let it kill us all. And that's the thing to keep our minds on. And that's why I feel that the proper response to climate change is adaptation. I mean, I wish the government in Britain, for example, would spend more effort and time thinking about the consequences, for example, of London flooding, which will happen not before too long, instead of worrying about trying to solve the problem of global heating, which they will never, ever do.
And the first question, the activist,
you've got well, being an activist, even although you probably wouldn't want me in your activist group, I would join any activist party in the part of the world where I live that was against wind turbines, because we live in a bit of Britain which is very like West County Cork in its ways. It's the beautifulest, the last bit that hasn't been seriously damaged by urban development and everything else. And I think to put a power plant of the wind turbine kind right in the middle of a very beautiful place is something that get me out. In fact, I've threatened to lie down in front of the bulldozers and get the media there when it happens. So I'm with you. I don't mean I'm against wind turbines in the right places, but I don't think they should be put in beautiful places.
I should tell you that in the biography of James that I read, there's a very interesting section on when he was a student and developed expertise in chemistry and explosives. He had a passionate feeling that he had a right to roam anywhere, and he used his expertise to remove any interventions that landowners were foolish enough to. So he has his. Okay, we'll.
Sorry, I'm afraid I'm probably going to be the last question.
Yes.
Here, you've actually just been talking about something which interests me. My name is Helen Doyle, and I'm just an ordinary citizen. I'm very concerned about the preservation of the beauty of the countryside.
Yes.
And you talk about the face of Gaia.
Yes.
It's very important that we preserve that, and that we shouldn't put up industrial-scale wind power plants in beautiful areas. Now, the problem with Ireland, as I see it, is we have a most beautiful countryside.
Absolutely.
And from your book, I see your point is that we shouldn't really be desecrating our beautiful places with large-scale industrial wind turbines when they're not going to have any impact or any appreciable impact on global climate change. And so I was just wondering, I know you've just dealt with that question, but perhaps if you could just make a final comment on that, how you feel about that. Why are we doing this? What is behind this rush to put up wind turbines in beautiful places when they're not going to curb climate change? In your book you mentioned something about the industrial nations, Denmark and Germany, I think, being behind this. I wonder if you could just elaborate a tiny bit on that, because I think it's something which is a concern to a lot of ordinary people in Ireland who don't actually have a voice in this issue. Sorry for going on a bit long, but I do feel quite strongly about this.
Well, so do I. I feel very strongly about it. You're quite right to say that the putting up of wind turbines in country areas is going to do very little to halt global warming at all, if anything. But it's considered a good green thing to do. But it's mostly the people who say that are urban people. They don't live in the countryside, probably are largely unaware of its existence. But to me, the countryside is the face of Gaia, because in the beautiful parts of Ireland, in the part of England where I live, it's an example of the way humans and the native world can live together in a fairly harmonious way. It's not perfect by any manner of means, but it's a damn sight better than the wasteland around a city. And it's as valuable and as beautiful and to be preserved as a cathedral or an art gallery. And we don't seem to properly appreciate it, and we shouldn't trash it.
Okay, I think we're way over time, actually, James. But just on all of your behalves, I suppose I'm a bit in the context of the two recent discussions. I did forestry and UCD, and it's one of the powers of professional acculturation that I'm the only person I think I know who loves Sitka spruce, just because I kind of got this 4 years of embeddedness just at the right age. And I even like windmills, although the right place is an important caveat. I think we've had a tour de force. James, I think it's really a very special occasion because, as he mentioned at the outset, his 90th birthday is looming in July. To take the time and energy and ambition to write the book that he's done, which is a terrific book again. Can I recommend? By the way, I'm on a 5% commission, but just but it's very, very special for us, I think, that he and Sandy took the time and the trouble to join us and gave of himself and themselves so much. He is, I guess we can say, he's an old man, and he's occasionally grumpy. But he's definitely not a grumpy old man. He's the exact opposite. He's full of terrific ideas and positivenesses. So on all of your behalfs, can we thank him and them very, very gratefully and generously.
Thank you. And I would like to thank James and Frank for a very stimulating evening, and all of you for joining us here this evening. The next event in this series of talks will take place on Wednesday, the 22nd of April, that's next week, at 7 p.m. in the Clinton Auditorium, when Professor Bob Schmuhl, who's Professor of American Studies at the University of Notre Dame and this year's Visiting Research Fellow at the John Hume Institute, will give a lecture on the exiled children and Easter 1916, America and Irish freedom, and you're most welcome to that. And I would like to invite you now to join us in the conservatory, where we can continue the conversation over a glass of wine. Thank you very much. Yes, no, I think everything worked. Yeah.
Well, I think it would be all great to do it on here.
No, inside.
Yeah. I do it here.
Oh, no.